Hello, welcome to Leetcode Solver. Today we are going to solve ninth problem in May Leetcoding Challenge, and the problem name is valid perfect square. Well, the given a positive integer num, write a function which returns true if the num is a perfect square, else return false. Do not use built-in library function such as sqrt. Yeah, 16 is true because it is the square of 4. 4 into 4 will be equal to 16. But in case of 14, it is false because like 3 into 3 is 9, 4 into 4 is 16, so it is in between 9 and 16. So, well, so if we are allowed to use squared, then what we will do, we'll just use squared, which will give us square root of something, square root of n, which is equal to sqrt, available in C++ num. So which will basically operate on double and double, I mean floating point in a number and give us the integer value if we assign it as an integer, like. And then after we can say that if we multiply this 2 times, like the square root of 16 is equals to 4, but square root of 13 is will be equal to 3 point something, but if we hold it in integer it will be like 3. And if we multiply 3 2 times, then what will be 3 into 3 will be 9, but actually there is a value is 13, so we say that this is not a perfect square. Well, in case of 16 we say that after squared we get 4, and we see 4 into 4 is equal to 16, so this is a perfect square. So in this way we could have solved the problem, but we are not allowed to use squared. Well, in that case what we can do is like the brute force approach. Let's think about the brute force approach. Brute force approach is just iterating over the elements starting from 1 till the num, and each time we square, like 1 into 1 will be something 1, and 2 into 2 will be equal to 4, 3 into 3 will be equal to 9, 4 into 4 will be equal to 16. And if we somehow see that this is crossing, like if we somehow like figure out that then while doing this operation some some square is crossing that given value, then we can stop right there. So if and the number we are interested is 23, and while doing so, like we calculated 1 2 3 and 4, both are 60, all of them are less than 23, and when we reach 25 by squaring 5, then we say that previous was 16, now it is 25, so there is no any way to 23 to be perfect square. So this is one solution, but if we keep on doing so, then we have to go like till square root of n at max to find the square root of n. Well, that would be big of square root complexity. So if we want to avoid that, then what we can do is like, as we can see that the value we are getting is like increasing order. So even after 25 the number will be like 6 into 6, which is 36. So as the numbers will be like increasing order, you can easily formulate the I mean we can find a some number, and then we can easily formulate that to which direction we should take on. Like initial range could be like starting from 1 to num itself, and after finding some mid value, say we found a 1 to mid value and mid plus 1 to num, then like while doing some operator over here in mid value, we have to decide whether we have to go to this range or that range. So what we can do is, like, based upon the mid values calculation, like if we calculate this and found it, the square of mid, like mid multiplied by mid, if we see that this is equal to num, then we are done, and we can return true. Well, if the case is like is greater than num, when it will happen, when this mid multiplied by mid will be greater than num, the the it will be in the case if the mid lies right side. So like in case we are interested in 23 and we found mid as a 6, like some point of time, and we multiplied 6 with 6 and found 36, then we can simply make a decision, then we can ignore this right side. So this basically lies in right side, mid basically lies in right side, so we can simply ignore this fact, this range is a whole range, this range, and we can move on to left side. The solution will be there, the solution will definitely not be in the right side. But if we found that this is less than num, then like in the case of 2 into 2 is 4, but we are interested in 23, so if it is less, then we can simply ignore all the numbers which is in the left side, because they will not give us the number which is equal to num, because the number in the left side will always be less than num, as the mid into mid is less than num, and all the value before of the mid are less than mid, so definitely the value produced by less than mid will definitely less than num. So we can conclude, and in that case we can ignore the left range, and we can move into right range. Well, so if we as we can see the pattern, we can apply binary search over here. So binary search is basically searching over the range, like basically partitioning the given range and making into two halves, and based upon mid's values condition, making a decision that we have to whether we have to go to the left side or right side in that case. So we if we can simply ignore one of the part, then we can apply binary search. And yeah, let's do binary search. So the range is initially, say, we can have range, low range as 1, high range we can keep it as num, although we can keep it square root of n. I mean but basically we can't use any other built-in function, so let's use normally num, or we can simply use num by 2 as well, but let's use num, that won't benefit. Well, let's do a binary search, so we can keep a condition as a while loop, that would be better. What happens? Okay, let's find out the mid is equals, it would be overflow. Say let's handle overflow by writing finding mid in this way, and now we have to find the mid multiplied by mid, so which may be greater than num, and it may be greater than which could be held by integer range. So let's put a long range to hold the multiplication. So we can typecast mid itself, mid multiplied with you don't need to bracket this. Well, if we do this, then we can make a decision, like if we found that, let's write the variable name, we can say this is a square square of mid. So if we found that square of mid is equals num, then we can simply return our answer as a true. And if we found that, as we analyzed earlier, if we found that this is less than num, then we have to move to the right side. Let's ignore the left side. We have to move to the right side. So let's make our range as mid plus 1. So we increases our left boundary. Otherwise we have to decrease our right boundary. Move to the left side. Well, finally, if we do not find anything, then in that case we have to return false. Let's run the program. Solution. Compile the solution. There is a compilation error in line number 64. What? Line number 64. Okay. Looks like there is a okay bracket issue. Let's compile again. Sounds good. Let's try with custom test case double 23 as we discussed earlier. It will be fail. Okay, false. Let's try with the perfect one, maybe critical one. And what else? 36 should be perfect. Awesome. Let's submit. Let's handle big range so that how many zeros? 1 1 2 3 4 5 6 7 8 9. It should not give any. Okay, any runtime error because of the integer range. We handled this, so it can't get any stack overflow. Submit. Accepted. Awesome. Well, as we are doing binary search, the complexity, time complexity is big of n, where n is given num, and space complexity is constant. Also, we can say big of 1. Well, why it is why the big of n? Big of log n. Time complexity is big of log n. Why big of a log n? I have already posted similar video in my previous video, similar content in my previous video. And the why space complexity is big of 1, because we are only using extra variables. Well, this is the algorithm. Binary search, we can also write down here binary search algorithm, and complexity is big of log n and space is big of 1. Okay, thank you so much for watching this video. Hope it helps you, and if you have any queries or any solution, any alternative solution or anything you would like to share, please feel free to comment in the comment section, and looking forward to see you in the next video. Have a nice day.